Hello, hello, hello. Well, you all know that it is spring break, but I wanted to record a couple of videos and upload them so that you can continue your learning while you are off from school. So I'm going to do a couple of presentations and talk about a couple of things that I've covered before in my classes. But if you haven't taken that class or if you want to learn it again, I think that this would be a great opportunity to learn some good stuff. We're going to do first the inner planets. I think this is a very interesting topic to discuss. And not a lot of people know much about our three planetary siblings that are closest to us. So let's check it out. We'll get right into it. So the four terrestrial planets are these four right here. Terrestrial meaning Earth-like, meaning rocky. So there are four of them: Mercury, Venus, Earth, duh, it's very Earth-like, and Mars. So these four planets make up the inner planets of our solar system, and they are called terrestrial. We can see the size differences between the four of them. Venus and Earth are almost identical in size. Venus is a little bit smaller. I believe it's about 97% of the mass of Earth. Earth is actually the largest of the inner planets and most massive. Mercury is the smallest. It is, however, very dense. It is mostly metal, and we'll talk about that in just a little bit. And then here, of course, is Mars. This picture is more true color. Oftentimes when we see pictures of Mars, it's very, very red. It is red, but it's more of a kind of a dull red. So let's talk about these inner planets. I'm going to skip over the Earth because there's so much to learn about the Earth that we have an entire class called Earth Systems about it. So we're just going to talk about these three: Mercury, Venus, and then Mars. And we will talk about them starting closest to the sun. So the terrestrial planets, they are called that because of their similarities to Earth. They're mostly rock and metal. So the outer planets, and maybe I'll upload a video about the outer planets. That is, if people want me to. The outer planets are mostly gassy. So they have a lot of gases like methane and ethane and hydrogen and helium. The inner planets are mostly made out of rock. So when we talk about the surface of the Earth being a rock, that's silicate oxide. And this here, this is the surface of one of our neighbors. It looks a lot like the moon. This is the surface of Mercury. It is very, very rocky. You can see these different craters here, and the craters have different characteristics, not just size, but you can see here that there's this white cloud around this crater here. There's more of a reddish brown tint to this one, and then you can see a larger, older crater in the background here, and then an even larger and older crater around there. So Mercury looks a lot like the moon. We'll talk about that in just a second. So the terrestrial planets are called that because they are rocky. So Mercury, so at the top of each slide that introduces a planet, you'll see its name, and then this right here, this is the symbol for the planet. And this looks kind of like the female symbol with something coming off the top. What this actually is a symbol for the god Mercury, which is similar to the messenger god in many of the stories from the Norse tradition, the Roman, and the Greek tradition, the messenger god. Okay, and the messenger god oftentimes is depicted with having wings coming off of his helmet, and so this kind of looks like horns. A lot of people think that this looks like almost like the devil, right? But this is actually a depiction of the messenger god, Mercury, and of course Mercury being the Roman god that is of speed and messenger, the messenger god. So if we look here, the closest planet to the sun, it's very, very little atmosphere. It has just a tiny bit of air. So when we're talking about an atmosphere, of course, we're talking about air, right? And again, it looks very much like the moon, more heavily cratered than the moon. It's kind of hard to tell in this picture, but there are more craters on Mercury than there are on Luna, our moon. It is 0.055 Earths in mass. So the Earth is much more massive than Mercury. It is also much larger. You can see the size here, 0.056 Earths. So it is just slightly more dense than the Earth. That probably has to do with the water. Mercury has very, very little water. Most of it is in little craters at the poles that stay in shadow, and it's ice. It doesn't have any liquid water. It has an 88 Earth day orbital period, so it goes around the sun every 88 days, 88 Earth days, right? And it has a huge, drastic swing in its temperatures. On the day side, so the side that faces the sun, it is 430 degrees Celsius, while on the night side is negative 173 degrees Celsius. That is a huge difference, right? So that's a difference of almost 600 degrees between night and day. That's because there's no atmosphere to keep in the heat during the night or to block out some of the sunlight during the day. So atmospheres oftentimes act as kind of blankets, but also kind of sun shades for planets. So they have the dual effect of being able to reflect away a little bit of the heat, but also keep it in when it's on the night side. So that's kind of just the basics on Mercury, but let's learn a little bit more about it. So its orbit is super strange, okay? So the planets, as you get further away from the sun, the planets take longer and longer to go around the sun. Mercury goes around the sun very, very quickly. That's actually where it got its name. Mercury is called Mercury, the swift messenger god, because he is so fast, right? Mercury moves quickly in the sky relative to all the other stuff. So one night it will be maybe 6 degrees above the horizon, and then another night it will be 8 degrees above the horizon, and then the next night it's 11 degrees above the horizon. It moves very quickly back and forth around the sky. It doesn't get very far from the sun because it's so close to the sun, it's going around. From our perspective, it doesn't really stray far from the sun from our point of view, but it does move very quickly back and forth. It has a very eccentric orbit, meaning that it gets much closer when it's closest and much farther away when it is far away. Its orbital period and its day are in a 2-to-3 ratio, meaning that its day is longer than its year. So it takes more time for it to spin on its axis once than it does for it to go around the sun. It also creates what's called a double sunrise. And let me show you this animation of the double sunrise on Mercury. Mercury. I'm just going to mute this here, but this is a very interesting animation. Let's check it out. So you can see here that the planet goes around very quickly in relation to its actual speed. And I don't know what these subtitles are. I think it's like Hungarian or something. But as it goes around, so you can see the sun comes up and moves through the sky. But what happens is that at certain points on the surface of Mercury, sometimes it gets so close in its orbit that it starts moving faster than it spins. And so you'll see a very interesting phenomenon here where the sun will rise as it goes up. So the sun comes up, and then as it approaches the sun, It starts speeding around, and the sun sets again, turns around, goes the opposite direction, and then rises again. Pretty cool. So the double sunrise on Mercury, it's a very, very interesting phenomenon. And the question is, should we really consider Mercury to be a planet? It is so small. It's smaller than many of the moons in our solar system, and it's just about the same size as our moon. So should we consider it a planet, or maybe should we consider it a dwarf planet? That's something that I'd want you to ask yourself. And you can see in this photograph that this is a bunch of different photographs put together to make one consistent image. Mercury spins so slowly and is so close to the sun, it's actually very difficult to get close to the sun. Not just because it's hot, but because you have to slow way down and orbiting the sun. It's very difficult to get there. And so Mercury was actually not fully mapped until not that long ago. For much of the history of the space age, we only had a map like this, a high detail map of 1/2 of Mercury's surface. All right, now let's talk about Venus. And we've all seen this symbol here before. This is what many people consider to be the female symbol. It is actually the symbol for the Roman goddess of beauty, Venus, also called Aphrodite in Greek or Freya in Norse. And so Venus here, Freya, also I want to go back to Mercury just really quickly. Mercury is, in the Norse tradition, is Odin, okay? And Odin is also where we get the name for the day of the week, Wednesday, Odin's Day, Wednesday. So Odin, so the days of the week are actually named after the planets. So Venus, or Freya, or Aphrodite, Freya, that's where we got Friday, Freya, Friday. Freya is the Norse goddess of beauty. Venus is the Roman goddess of beauty. They're the same character, essentially, in those traditions. It is the hottest planet in the solar system, and we'll talk about that in a second. It takes more time, again, to rotate once than it does to go around the sun. So it takes 224 days, 224 Earth days, excuse me, to go around the sun, and 243 Earth days to rotate once on its axis. Its size and mass are both 0.94 of Earth's. So earlier, I think I said 0.98 or 0.97. So it is 0.94 for both size and mass. It's very, very similar to Earth. It rotates in the opposite direction as the other planets. So all the other planets rotate like this. Venus rotates like this. It is backwards to the rest of the planets. We don't really know why that is, but a lot of astronomers hypothesize that it was because something very, very large actually struck that planet. All right. The runaway greenhouse effect of Venus. So it is very hot, very, very hot on the surface of Venus, and not just on the day side, on the entire planet. And that is because it's thick atmosphere, primarily comprised of carbon dioxide, which is a greenhouse gas, right? Carbon dioxide traps most of the heat from the sun, and so it's like an oven with the sun supplying the heat and then the atmosphere just keeping that heat in. 430 degrees Celsius is the average temperature, which is hot enough to melt lead. So your oven at home can maybe get to about 250 degrees Celsius. This is much, much hotter. This is like a kiln, so a very, very powerful, or like a forge, something that is so hot that it can melt metal. So lead would melt on the surface of Venus, and this has actually been very problematic for some of the spacecraft that we've tried to send to the surface of Venus. Most of them only lasted a few seconds before their computer parts completely fried. So this is a very interesting planet for sure, Venus. And you can see here, this is actually what the what Venus looks like underneath its clouds. This is using cloud penetrating radar. So we can use radar that goes through the clouds and we can map the surface of Venus. This is what Venus looks like just if you were to look at it. These very, very thick clouds. You can see they have kind of a yellowish, brownish tint to them with a whitish tint at the poles. So it's very hot on Venus, and that is because of the greenhouse effect. That's the same thing that is causing climate change here on Earth. We're putting too much carbon dioxide into the air from burning fossil fuels like gasoline and oil and coal. And so we are doing the same thing to Earth as Venus has had in the past. We probably won't get as bad as Venus, fingers crossed, but we don't want to get close to a runaway greenhouse effect. That would be very, very bad. And runaway meaning, of course, that it just gets worse and worse and worse. So other facts about Venus. The clouds are made out of sulfuric acid. So those thick clouds you can see here are made out of sulfuric acid, which is not fun. All right. So the acid clouds on Venus would be very destructive to anything like your skin or your hair or anything like that. It is covered in volcanoes, most of which are dormant. We're not 100% sure, but it has a whole bunch of volcanic rock. And then it is the brightest thing in the sky, called the morning and evening star. You can see it here. So after the sun and the moon, it is the brightest thing in the sky. And if you go outside at dusk or right before sunrise, maybe you'll see something very, very bright, and that is Venus. And that is why it's called the evening and morning star. You can only see it right around sunset or sunrise because, again, it's closer to the sun. And so from our point of view, it doesn't get very far from the sun. But Venus is super, super bright, sometimes being 5 or 6 times brighter than any star. It goes through phases from our point of view, just like the moon. So if you have a really good telescope, you can see these phases. And that was actually first seen by Galileo. And he used his telescope to look at Venus and has some very, very cool sketches of Venus. Venus sketch Galileo. So if you look at this here, oh, that's a very small image. Have any bigger images here? Maybe. So here it is. You can see that he sketched when it was in a crescent, and then about a quarter, and then half, a little bit more than half, and then the full circle. The reason why the largest of these drawings is the crescent is because we can see the crescent of Venus when it is closest to us, which makes sense. As the two planets go around the sun, we can see it in its crescent form when it is closest to us, and when it is farthest away from us, we can see it in its full circle, because the sun is actually illuminating the entire half facing us. It's very, very hard to see it in this full phase, however, because it's really close to the sun and sets with the sun and rises with the sun. So let's go back here. Goes through phases like the moon. Interestingly enough, the moon in its crescent phase, and then with Venus right next to it, that is actually the symbol of Islam, interestingly enough. So the crescent and star that you see on many flags, like for instance, let's look up Turkey. No, not Turkey. Turkey flag. Crescent and star, that's the symbol of Islam, and Turkey is technically an Islamic state. The crescent and star, this is the moon, and this is Venus. So that is the symbol of Islam. So pretty interesting how these things get connected together. All right. I'll let you watch this on your own time. There is a video that talks about possible life on Mars right now, or not on Mars, on Venus. It is very, very interesting. It talks about how possibly life could be living in the clouds of Venus, but we're not going to watch it together right now. Okay, now we move on to Mars. And so with Venus, we have this symbol here, the female symbol. So we use the female symbol. I'm not exactly sure why this symbol is the way that it is. Some people speculate that it is referring to Aphrodite's mirror, but I don't know exactly what it's referring to here. If we look at the symbol for Mars, this is the same symbol for male. And this refers to the shield and spear, because Mars is the god of war. And Mars being connected to Ares in the Greek mythology tradition, as well as Tyr in the Norse tradition. So Tyr, Tyr, is the Norse god of war, and that is where we get the day Tuesday. So far we have covered Wednesday, Odin's day, that's Mercury. Friday, Freya, which is Venus's day. And of course, Mars, which is Tyr, Tuesday. So Tuesday, Wednesday, and Friday are named after Mars, Mercury, and Venus, respectively. Pretty cool. So this is an unusual planet, Mars. It's kind of, I like to refer to Mars, Earth, and Venus as triplets. And Venus and Earth are like so if you have a set of triplets and you have two identical siblings and then one fraternal sibling and they're born at the same time, they're all kind of similar. They're siblings, but I kind of look at Earth and Venus as identical twin sisters, and Mars just happens to be their triplet awkward brother. Venus is crazy and she will destroy you, and Earth is super nice and very friendly, and Mars is just kind of an awkward, shy nerd. I wouldn't know anything about that from personal experience. Okay, so the small awkward triplet of the Earth and Venus has a thin atmosphere, 1% of the thickness of Earth's. That atmosphere is almost completely carbon dioxide and helps to retain a little bit of heat, but not very, very much, because it is so thin. If we talk about Venus's atmosphere, the atmosphere on Venus is so thick that it would crush a submarine. So you could take a submarine to the surface of Venus and it would crush it, because it is, the surface pressure on Venus is way, way, way higher than the pressure at the bottom of the ocean here on Earth, which is pretty crazy. It has a much thicker atmosphere than we could imagine, that we experience here on Earth. And so Venus will kill you, all right? It's hot, has acidic clouds, and it crushes things. So Venus is not a great place to visit, at least not on the surface. Upland clouds, that's a better place to go visit. All right, sorry, I keep on going back and forth. It takes an orbital period of 686 days, Earth days, to go around the sun for Mars. So it's about a little bit less than twice that of Earth's orbital period. And it is very, very similar to the rotational period of Earth, 24 hours, 39 minutes. So here on Earth, we have a 24-hour rotational period. On Mars, it's 24 hours, 39 minutes. And that is referred to as a sol, or sol, which is the name of the sun. I'll let you absorb all this information here. You can see in this image, of course, we have Mars. Mars has its ice caps. These are actually ice caps made out of water and carbon dioxide, which is dry ice. And then, of course, its iconic red tint. And then here, these two dots in the picture, those are the two moons of Mars. Venus and Mercury do not have moons. Mars has two very, very small moons, and we'll talk about them in just a second. Mars has a lot of interesting things. It used to have water on the surface. We know that. We know that because we can see ancient shoreline. Most of the northern hemisphere of Mars used to be covered in water, and it had that water about 4 billion years ago to about 2 billion years ago, at which point it just started to boil off because its atmosphere was so thin and couldn't keep the water there. Water has been lost over time. We see it in the evidence, again, these shorelines and these minerals that can only form in water. And hopefully, when we terraform Mars, and that's kind of a discussion for a different class, but one day there might actually be water back on the surface of Mars, liquid water. We do know that there is some frozen water kept up in the soil of Mars. We hope to someday use that for colonization and so forth, but that's, again, for a different discussion. Something very interesting about Mars is it has the largest mountain known in the solar system. It is Olympus Mons, which is a mountain which is about the same size as the state of Arizona or New Mexico. Very similar size states there. So the entire state of New Mexico would just barely cover this mountain at its base. The altitude is huge, all right? So it is 25 kilometers tall, which is, just for reference, 3 times higher than Everest here on Earth. So it is 3 times the height and many, many, many times the base width of the largest mountain here on Earth. Which technically, actually, the largest mountain on Earth is the Big Island of Hawaii, if you measure it from its base, and not its actual elevation. Olympus Mons, pretty cool. It is a dormant volcano. It is a very ancient shield volcano, just like the volcanoes on the Hawaiian Islands. Valles Marineris, which is another very interesting topographical structure on the surface of Mars. It is the Grand Canyon of Mars. Well, really, it's the grandest canyon. We talk about the Grand Canyon here on Earth. It is so grand, but for comparison, Valles Marineris is gigantic. So Valles Marineris, you can see it here. You can see very, very clearly Valles Marineris from space on Mars. It is 4,000 kilometers long, which is 8 times the length of the Grand Canyon. Grand Canyon only being 50 kilometers long. And it is 7 kilometers deep, which is 7 times deeper than the Grand Canyon here on Earth. It is a truly massive scar on the side of the planet Mars. It would be a good place for a location for a Mars colony because at the bottom that we would have higher air pressure, possibly some clouds could form of water. Kind of an interesting idea. If you want to learn more about that, there's a fantastic book that talks about it. It's called Mars by Ben Bova, and he discusses in that book how we could use Valles Marineris as a first location for colonization. Okay, and then just for reference, these 3 dots here are also very large dormant volcanoes. They're not as large as Olympus Mons, which is just outside of the picture here on the other side of the planet, but these are 3 dormant volcanoes, just like Olympus Mons. The ice caps. If you have a good telescope, and I've just barely been able to see the ice caps on Mars on a very, very clear night, you can see these ice caps, and these are primarily made out of carbon dioxide, which is dry ice. There's a lot of water, but mostly carbon dioxide. and it is cold, cold, cold. So Mars is really cold because of how thin the atmosphere is. Really, I mean, the warmest that it gets on the surface of Mars right now is about 0 degrees Celsius, which is freezing. And that's like noon on the equator in the very, very height of summer. It is very, very rare that it gets that warm. Most of the time on Mars, it's negative 200 or so degrees Celsius. It's very, very cold. So that is all that I have to discuss about these amazing planets. Mercury, very little air, very small, a lot of metal, spins weird, orbits the sun weird. It's a very interesting place. Venus, hot, sulfuric acid clouds, huge pressure. It's bright in the sky. Very beautiful to look at. Wouldn't be great to go visit. And of course, Mars, everybody's favorite to talk about these days. Thin atmosphere, it's very cold, a little bit small and awkward, similar day to Earth. So interesting planets for sure. I hope that you learned a thing or two about this amazing topic of the inner planets. I think it's a really cool topic. Such amazing places. Someday, I'm sure that people will visit all three of them. It's just a matter of when. Thanks for tuning in. You guys are great. Keep on learning.